Ever pondered what exactly constitutes the matter that surrounds us? Well, the answer lies in a fascinating world of subatomic particles, a world where the seemingly impossible becomes the norm. Today, we delve into the intriguing realm of quarks, hadrons, and elementary particles. To grasp the concept of quarks, imagine the tiniest pieces of matter that exist. Quarks are so minuscule that they baffle scientists to this day, as they remain unobservable due to a phenomenon known as color confinement. This means that quarks are never found alone. They always exist in groups. Now, imagine these quarks coming together to form composite particles. These composite particles are what we refer to as hadrons. Picture a close-knit family of quarks, with the most stable members being protons and neutrons. These protons and neutrons are the building blocks of atomic nuclei and all commonly observable matter. But what about the other particles, the ones that aren't made up of smaller components? These are what we call elementary particles. They're like the loners of the particle world. These particles, fascinatingly enough, have no measurable internal structure. It's still a mystery whether they're composed of other particles. They are the fundamental objects of quantum field theory. A crucial aspect to understand about hadrons is that their properties are primarily determined by their so-called valence quarks. For instance, a proton is composed of two up quarks, each with an electric charge of 2/3, and one down quark with an electric charge of -1/3. Adding these together gives the proton a total charge of +1. Despite quarks also carrying a color charge, hadrons must have zero total color charge. This is due to the same phenomenon we mentioned earlier, color confinement. It's as if the universe has its own strict color coordination rules for these particles. To summarize, quarks are the smallest known particles, always found in groups, and combine to form composite particles called hadrons, with protons and neutrons being the most stable. These protons and neutrons are the building blocks of atomic nuclei and all commonly observable matter. Elementary particles, on the other hand, are the loners of the particle world, with no measurable internal structure. They are the fundamental objects of quantum field theory. Finally, the properties of hadrons are primarily determined by their valence quarks. And despite quarks carrying a color charge, hadrons must have zero total color charge due to color confinement. The world of subatomic particles is indeed a fascinating one, filled with intriguing concepts and phenomena that challenge our understanding of the universe as we know it. So next time you look around, remember that everything you see is a result of these tiny particles interacting in ways that continue to astound scientists worldwide.